Abu Rayḥān Muḥammad ibn Ahmad Al-Bīrūnī, known as Al-Bīrūnī in English, was a Khwarezmian Iranian Muslim scholar and polymath. Al-Bīrūnī is regarded as one of the greatest scholars of the medieval Islamic era and was well versed in physics, mathematics, astronomy, and natural sciences, and also distinguished himself as a historian, chronologist, and linguist. He was conversant in Khwarezmian, Persian, Arabic, Sanskrit, and also knew Greek, Hebrew and Syriac. He spent a large part of his life in Ghazni in modern-day Afghanistan, capital of the Ghaznavid dynasty, which was based in what is now central eastern Afghanistan. In 1017 he travelled to the Indian subcontinent and authored Tarikh al-Hind. After exploring the Hindu faith practiced in India, he was given the title founder of Indology. He was an impartial writer on customs and creeds of various nations, and was given the title Al-Ustad for his remarkable description of early 11th century India. He also made contributions to earth sciences, and is regarded as the father of geodesy for his important contributions to that field, along with his significant contributions to geography. Life. He was born in the outer district of Kath, the capital of the Afghanid dynasty of Khwarezm. The word Biruni means, for the outer district, in Persian, and so this became his nisbah. Al-Bīrūnī equals the Birunian. He spent the first 25 years of his life in Khwarezm, where he studied Islamic jurisprudence, theology, grammar, mathematics, astronomy, medics and other sciences. The Iranian Khwarezmian language, which was the language of Biruni, survived for several centuries after Islam until the Turkification of the region, and so must some at least of the culture and law of ancient Khwarezm, for it is hard to see the commanding figure of Biruni, a repository of so much knowledge, appearing in a cultural vacuum. He was sympathetic to the Afrids, who were overthrown by the rival dynasty of Ma'munids in 995. He left his homeland for Bukhara, then under the Samanid ruler Mansur the son of Nuh. He corresponded with Avicenna, and there are extant exchanges of views between these two scholars. In 998 he went to the court of the Ziyarid Emir of Tabaristan, Shams al-Moali Abul Hasan Gabuz ibn Wishlamga. There he wrote his first important work, Al-Athar al-Baqiyya, and Al-Quran al-Khaliyya, on historical and scientific chronology, probably around 1000 AD, though he later made some amendments to the book. He also visited the court of the Babandid ruler Al-Ma'zuban, accepting the definite demise of the Afrids at the hands of the Ma'munids. He made peace with the latter, who then ruled Khwarezm. The court at Gorganj was gaining fame for its gathering of brilliant scientists. In 1017, Mahmud of Ghazni took Ray. Most scholars, including Al-Bīrūnī, were taken to Ghazni, the capital of the Ghaznavid dynasty. Biruni was made court astrologer and accompanied Mahmud on his invasions into India, living there for a few years. Biruni became acquainted with all things related to India. He may even have learned some Sanskrit. During this time he wrote the Kitab Tarikh al-Hind, finishing it around 1030. Mathematics and Astronomy. 95 of 146 books known to have been written by Biruni were devoted to astronomy, mathematics, and related subjects like mathematical geography. Biruni's major work on astrology is primarily an astronomical and mathematical text. Only the last chapter concerns astrological prognostication. His endorsement of astrology is limited insofar as he condemns hoary astrology as sorcery. In discussing speculation by other Muslim writers on the possible motion of the earth, Biruni acknowledged that he could neither prove nor disprove it, but commented favorably on the idea that the earth rotates. He wrote an extensive commentary on Indian astronomy in the Kitab Tarikh al-Hind, in which he claims to have resolved the matter of Earth's rotation in a work on astronomy that is no longer extant. His Miftah-ilm al-He rotation of the Earth does in no way impair the value of astronomy, as all appearances of an astronomic character can quite as well be explained according to this theory as to the other. There are, however, other reasons which make it impossible. This question is most difficult to solve. The most prominent of both modern and ancient astronomers have deeply studied the question of the moving of the Earth, and tried to refute it. We, too, have composed a book on the subject called Miftah-ilm al-He, in which we think we have surpassed our predecessors, if not in the words, at all events in the matter. In his description of Sigzi's astrolabe, he hints at contemporary debates over the movement of the Earth. He carried on a lengthy correspondence and sometimes heated debate with Ibn Sina, in which Biruni repeatedly attacks Aristotle's celestial physics. He argues by simple experiment that vacuum must exist. He is amazed by the weakness of Aristotle's argument against elliptical orbits on the basis that they would create vacuum. He attacks the immutability of the celestial spheres, and so on. In his major extant astronomical work, the Masuda Canon, Biruni utilizes his observational data to disprove Ptolemy's mobile solar apogee. More recently, Biruni's eclipse data was used by Dunthorne in 1749 to help determine the acceleration of the Moon, and his observational data has entered the larger astronomical historical record and is still used today in geophysics and astronomy. Physics. Al-Bīrūnī contributed to the introduction of the experimental scientific method to mechanics, unified statics and dynamics into the science of mechanics, and combined the fields of hydrostatics with dynamics to create hydrodynamics. Geography. Biruni also devised his own method of determining the radius of the Earth by means of the observation of the height of a mountain, and carried it out at Nandana in Pindadan Khan. Pharmacology and Mineralogy. Biruni's most important work was a major pharmacopoeia, the Kitab al-Sayd fi al-Tib, describing essentially all the medicines known in his time. It lists synonyms for drug names in Syriac, Persian, Greek, Baluchi, Afghan, Kurdi, and some Indian languages. Due to an apparatus he constructed himself, he succeeded in determining the specific gravity of a certain number of metals and minerals with remarkable precision. History and Chronology. Biruni's main essay on political history, Kitab al-Muzammar fi Akhbar-Arazm, is now known only from quotations in Bayhaqi's Tariq-e Masudi. In addition to this, various discussions of historical events and methodology are found in connection with the lists of kings in his Al-Athar, Al-Baqiyya, and in the Canon, as well as elsewhere in the Athar, in India, and scattered throughout his other works. History of religions. Biruni is one of the most important Muslim authorities on the history of religion. Al-Bīrūnī was a pioneer in the study of comparative religion. He studied Zoroastrianism, Judaism, Hinduism, Christianity, Buddhism, Islam, and other religions. He treated religions objectively, striving to understand them on their own terms rather than trying to prove them wrong. His underlying concept was that all cultures are at least distant relatives of all other cultures because they are all human constructs. What Al-Bīrūnī seems to be arguing is that there is a common human element in every culture that makes all cultures distant relatives, however foreign they might seem to one another. Al-Bīrūnī divides Hindus into an educated and an uneducated class. He describes the educated as monotheistic, believing that God is one, eternal, and omnipotent, and eschewing all forms of idol worship. He recognizes that uneducated Hindus worship the multiplicity of idols, yet points out that even some Muslims have adopted anthropomorphic concepts of God. Indology. Birūnī's fame as an Indologist rests primarily on two texts. Al-Bīrūnī wrote an encyclopedic work on India called Tarikh al-Hind, in which he explored nearly every aspect of Indian life, including religion, history, geography, geology, science, and mathematics. He explores religion within a rich cultural context. He expresses his objective with simple eloquence. I shall not produce the arguments of our antagonists in order to refute such of them as I believe to be in the wrong. My book is nothing but a simple historic record of facts. I shall place before the reader the theories of the Hindus exactly as they are, and I shall mention in connection with them similar theories of the Greeks in order to show the relationship existing between them. An example of Al-Bīrūnī's analysis is his summary of why many Hindus hate Muslims. He explains that Hinduism and Islam are totally different from each other. Moreover, Hindus in 11th century India had suffered through waves of destructive attacks on many of its cities, and Islamic armies had taken numerous Hindu slaves to Persia, which claimed Al-Bīrūnī contributed to Hindus becoming suspicious of all foreigners, not just Muslims. Hindus considered Muslims violent and impure, and did not want to share anything with them. Over time, Al-Bīrūnī won the welcome of Hindu scholars. Al-Bīrūnī collected books and studied with these Hindu scholars to become fluent in Sanskrit, discover and translate into Arabic the mathematics, science, medicine, astronomy and other fields of arts as practiced in 11th century India. He was inspired by the arguments offered by Indian scholars who believed Earth must be globular in shape, which is the only way to fully explain the difference in daylight hours by latitude, seasons and Earth's relative positions with moon and stars. At the same time, Al-Bīrūnī was also critical of Indian scribes who he believed carelessly corrupted Indian documents while making copies of older documents. Al-Bīrūnī's translations as well as his own original contributions reached Europe in 12th and 13th century, where they were actively sought. While others were killing each other over religious differences, Al-Bīrūnī had a remarkable ability to engage Hindus in peaceful dialogue. Muḥammad Yassin puts this dramatically when he says, "The Indica is like a magic island of quiet, impartial research in the midst of a world of clashing swords, burning towns, and burned temples." Works. Most of the works of Al-Bīrūnī are in Arabic, although he wrote one of his masterpieces, the Kitab al-Tafhim, apparently in both Persian and Arabic, showing his mastery over both languages. Birūnī's catalogue of his own literary production up to his 65th lunar, 63rd solar year lists 103 titles divided into 12 categories: astronomy, mathematical geography, mathematics, astrological aspects and transits, astronomical instruments, chronology, comets, an untitled category, astrology, anecdotes, religion, and books of which he no longer possesses copies. His extant works include critical study of what India says, whether accepted by reason or refused, also known as the Indica, a compendium of India's religion and philosophy. The Book of Instruction in the Elements of the Art of Astrology, the remaining signs of past centuries, a comparative study of calendars of different cultures and civilizations, interlaced with mathematical, astronomical, and historical information, the Masuda Canon, an extensive encyclopedia on astronomy, geography, and engineering, named after Masud, son of Mahmud of Ghazni, to whom he dedicated Understanding Astrology, a question-and-answer style book about mathematics and astronomy, in Arabic and Persian. Pharmacy, about drugs and medicines. Gems, about geology, minerals, and gems, dedicated to Muḥammad, son of Masud. Astrolabe, a historical summary book. History of Mahmud of Ghazni and his father.
History of Khwarezm, Persian Work. Biruni wrote most of his works in Arabic as the scientific language of his age. However, his Persian version of the Al-Tafhim is one of the most important of the early works of science in the Persian language, and is a rich source for Persian prose and lexicography. The book covers the quadrivium in a detailed and skilled fashion. Legacy. The lunar crater Al-Bīrūnī and the asteroid 9936 Al-Bīrūnī were named in his honor. In June 2009, Iran donated a scallop pavilion to United Nations office in Vienna, which is placed in the central memorial plaza of the Vienna International Center. The Persian Scholars Pavilion at United Nations in Vienna, Austria, is featuring the statues of 4 prominent Iranian figures, highlighting the Iranian architectural features. The pavilion is adorned with Persian art forms and includes the statues of renowned Iranian scientists Avicenna, Abu Rayḥān, Biruni, Zakaria Razi and Omar Khayyam.